Alright, so we just looked at shortest job first, and I told you it is non-preemptive, and I ended that segment by telling you you don't know, processes keep coming in at different time instances, so you cannot always find the minimum or the shortest process. So on that note, I think it is a good time to introduce shortest remaining time first, which is the preemptive version of shortest job first. So here, as you can see, like I mentioned in the previous video, arrival times are different. So you have a process P1 which arrives at time 0, P2 arrives at 1, P3 at time 2 and P4 at time 3, and each have their burst times. So what shortest remaining time first does is, at every instance of time, you calculate which process has minimum time left, which process needs the fewest number of cycles at this instance. So when I explain the example, it will become more clear. Remember that this is preemptive. So at time instance 1, you could choose process P1 because that needs the fewest cycles, and then at time instance 2, you could happen to choose process P2. So P1 will be stalled or paused, P2 will be executed. Again at time instance 3, if P1 happens to be the one which needs fewest cycles, then you will go back to P1. So that switching will happen here. So that is what we mean by preemptive. So we'll look at the example and we'll understand. So you have these processes. So at time interval 0, P1 is the only process that is in my queue. So irrespective of shortest, longest, first come, last come, I have to choose P1 for the first instance. At time instance 1, I have P1 and P2. This one needs 7 units now because 1 unit has been executed already. So P1 will need 7 units. This one needs 4 units. So this being P2 being the shorter one, I will obviously pick P2. So at time instance 2, I will again check. P1 needs 7 units, P2 needs 3 units, and this one has just arrived and it needs 9 units. So again, P2 being the minimum, I will use P2 for the next time instance. Again at time instance 3, I will check. This will be a 7, this will be I think 2 units, this is a 9. Again P2 being minimum. At the third instance also I will put P2. Again at time instance 4, I will check. P2 is the minimum, so I do P2. And at time instance 5, P2 has been completed and all of these have come in. Now again at time instance 5, I check. P1 needs 7 units, P3 needs 9 units, P4 needs 5 units. Now P4 is the smallest, so I will take P4 for the first one instance of time. At time instance 6, again I check. There are no new arrivals anymore, which means I have all my data. So once all the processes have arrived, it becomes pretty much the same as shortest job first. So while something is arriving, while processes are arriving every time instance, you have to pause after every one cycle or every one instant of time, and you have to check the existing processes, you have to check the new arrivals, you have to see how much time is required, you have to pick the minimum. Note that by time required, I mean it could be the burst time itself if the process has not been executed yet, or like in the case of P1, we already ran it for one instance here, one time instance here, and then we took it out of the queue, so this 8 would have become a 7 and so on and so forth. So that subtraction is something you need to keep track of in every iteration. So at every time instance, you keep checking for what are the processes which are in my queue so far, how much time does each need, which is the minimum. You pick that minimum, you put it in the queue, you run it for 1 second. Again at the next time instance, you repeat the process. Once all the processes have arrived, so after time instance 3, there is no more new arrivals. So this becomes the same as non-preemptive shortest job first scheduling. So this is how your Gantt chart will look, and I am sure you are by now familiar with how to compute the wait time and turnaround time. So this is very similar to shortest job first in terms of the logic, but because we saw in shortest job first that you cannot predict what jobs are going to come, you will have to deal with things on the fly as and when they come. This is a more practical variant of that, which is more suitable for real-time systems. So that's it about preemptive SJF, also known as shortest remaining time first.